Okay, awesome. Hi, everyone. My name is Mihir, and I'm an advisory intern out of the San Francisco office.
Hello, my name is Evan, and I am a tax intern at the San Francisco office.
Hi, my name is Lauren, and I am an audit intern at the Los Angeles office.
Hi, I'm Alyssa, and I'm an intern at the Orange County Office in Audit.
Hi, I'm Toko. I am an audit intern at Silicon Valley office.
And we are the members of team number 398. Technology is the future of financial services, and it requires lots of energy and electricity to function. Data sustainability comes into play here since it ensures that best business practices do not negatively impact our environment. In the new era of work from home and a digital revolution that's currently ongoing, data is the connection between every single part of our society. Data sustainability will ensure that our future is carbon neutral because we will properly understand how to store and process big data while determining streamlined processes and policies that allow companies to save on time, energy, and money. Solutions that we'll outline today include number 1, making cloud systems more green, and number 2, making sure that data centers reduce their carbon footprint.
Data volume has increased drastically, along with the use of cloud systems to store this data. Rather than using single-use technologies, implementing cloud solutions allows for a more centralized storage of data and less usage of hardware. We could implement renewable energy sources to power these large cloud services. According to The Economist, between 70% and 90% of data that organizations collect is dark data that incurs unnecessary energy costs to transmit and store without being turned into insights and business opportunities. Making sure to incorporate a cloud that runs on 100% renewable energy because that will decrease companies' emissions. Company data centers account for about 2% of all data emissions, and placing an emphasis on the infrastructure of data centers is imperative to enact change. Specifically, incorporating lights, cooling systems, and automation can improve efficiency when moving towards a green cloud.
And according to the Inventory of U.S. Greenhouse Gas Emissions and Sinks, a report from the EPA, although coal use accounted for about 54% of CO2 emissions from the sector, it represented only 20% of the electricity generated in the United States in 2020. With that, we plan on using data to display how beneficial it is to move towards green cloud systems. Many major companies have implemented the use of cloud centers to minimize their overall emissions. With that, we chose data sets that explain how large companies have already been able to create an energy-efficient data center design. Specifically, the U.S. Department of Energy released research on how companies can begin increasing their data efficiency by implementing cooling systems. Ultimately, the cooling systems improve efficiency by taking advantage of surplus and redundant capacity to actually improve efficiency, which in turn reduces the carbon footprint and maintenance traffic in the data center.
Data centers have become very important to businesses. According to a Stanford study, most big data centers could slash their greenhouse gas emissions by 88% by switching to efficient off-the-shelf equipment and improving energy management. Many data centers require the heating and cooling of machinery. In particular, processors and data centers are not energy efficient and perform computations of just 3% to 5% of their maximum capacity. The utilities and IT departments have separate budgets, and neither operate with the goal of saving the company money overall. The IT people don't care about by putting in an efficient server because they ultimately don't pay the electric bill. Once you fix the institutional problem, the company can move quickly because the needed equipment is off the shelf and the energy management practices are well understood.
Most green data centers are efficient with their financial and energy resources. These centers will typically locate server farms in cool climates like the US Northwest, Sweden, and Iceland. They purchase processors that are less sensitive to heat, and they use efficient cooling equipment and airflow management. According to the United States Data Center Energy Usage Report, the energy used by the nation's servers and data centers is significant. In a 2007 report to Congress, the data center sector was estimated to have consumed about 61 billion kilowatt hours in 2006, which is 1.5% of total U.S. electricity consumption, for a total electricity cost of about $4.5 billion.
Overall, you can see how storing data is very expensive and costly to a lot of companies while requiring tons of years to make sure that it is energy efficient. We believe that a push towards data sustainability now more than ever is very pressing. Thank you.